Hello, in this lecture we'll find out the length of line segment X using two different methods. In the drawing we have quadrilateral ABCD. We know that side AB equals to 5 units, side AD equals to 3 units, side DC equals to 6 units, and angle ABC equals to angle DCB equals to theta, and angle ADC, this angle is a right angle, it is equal to 90 degrees, and we want to find out the length of line segment BC that is actually equals to X. So first of all, we'll make a construction. We will extend side VA and side CD until they intersect with each other. And you will define the intersection point between side BA, the extended side BA, and the extended side CD as point E. This point is point E. So we actually created here triangle EBC. In this triangle EBC we have two angles that are equal to each other. In the next step I will present to you a new rule that is actually rule number 1. According to rule number 1, in front of equal angles in a triangle there are equal sides. So I'll write it down. In front of equal angles in the triangle there are equal sides. I'll read rule number 1 again. According to rule number 1, in front of equal angles in the triangle, there are equal sides. So here, if we focus on triangle EBC, in triangle EBC, it is given us the question that angle EBC equals to angle ECB equals to theta. Angle EBC is equal to angle ECB, and both angles are equal to theta according to what is given us in the question. Therefore, we will derive from it that according to rule number 1, side EB equals to side EC. Side EB equals to side EC because of the fact that those two sides are located in front of equal angles EBC and ECB. So EB equals to CD. This will be question number 1. From the drawing, it is very easy to see that side EB equals in its length to 5 plus AE. So we substitute EB by 5 plus AE. While side, actually here EB equals to EC, of course. EB equals to EC. Here EB equals to EC. Again, because of the fact that those two angles are equal to each other, it means that EB, according to rule number 1, EB equals to EC. So here EB equals to EC, and EC, for the drawing, it is already to see that EC equals to 6 plus ED. EC equals to 6 plus ED, so we substitute EC by 6 plus ED. Okay, so according to equation number 1, 5 plus ED equals to 5 plus AE equals to 6 plus ED. We will subtract 5 from this equation number 1, and we will get that according to equation number 1, AE equals to 6 minus 5 is 1 plus ED. So AE equals to 1 plus ED according to equation number 1. We will define AE as A. Here, AE is equal to, we will define ED as A. We define ED as A. So here ED equals to A according to our definition. So we can write here that ED equals to A. So we substitute ED by A in equation number 1, and we get that AE equals to 1 plus ED. ED is A according to our definition, so we substitute ED by A. So in conclusion, we found out that according to equation number 1, AE equals to 1 plus A. Here AE equals to 1 plus A. Actually, before the construction, we had quadrilateral ABCD, and side CD is one side of quadrilateral ABCD, therefore it is absolutely a straight line. And after that, we extended the straight line CD by a straight line, and we created EC, line segment EC. So when you extend the straight line by a straight line, the result must be a straight line. So we extended the straight line CD by a straight line, and we got the line segment EC. Therefore, line segment EC must be a straight line, because when you extend a straight line by a straight line, the result must be a straight line. Therefore, line segment EC is a straight line. So we can write down that EC is a straight line. We have already related to segment line EC as a straight line because of the fact that in triangle EBC, EC is one side of triangle EBC. Therefore, for this reason only, this is absolutely a straight line. Okay, so EC is a straight line, and we also have rule number 2. According to rule number 2, the sum of the angles on one side of a straight line is equal to 180 degrees. I'll repeat on rule number 2 again. According to rule number 2, the sum of the angles on one side of a straight line is equal to 180 degrees. Again, here the sum of the angles on one side of a straight line is equal to 180 degrees. So we know that line segment EC is a straight line. So if we focus on this side of the straight line EC at point D, then the sum of the angles must be equal to 180 degrees according to rule number 2. So we'll focus on this side of the straight line EC at point D. So which angles we have at this side of the straight line EC at point D? We have here 90 degrees. And we have here this angle ADE. In total, the sum of those two angles must be equal to 180 degrees according to rule number 2. So here we will subtract 90 degrees from this equation, and we will get that the missing angle ADE, is equal to 180 degrees minus 90 degrees, it is 90 degrees. So this angle is a right angle, it is equal to 90 degrees. Actually, because of the fact that angle ADE equals to 90 degrees, it means that triangle ADE is a right angle. This right green triangle, or triangle ADE, the green triangle, is a right angle. So we can implement the Pythagoras theorem on the green right triangle EDA. So the square of the hypotenuse equals to the sum of the squares of the perpendiculars. So in the right triangle EDA, here by PT, that is the relation for Pythagoras theorem, we will get that the square of the hypotenuse is AE squared. Equals to the sum of the squares of the perpendiculars, that is to say it equals to AD squared plus AD squared. So I'll repeat again. According to the Pythagoras theorem, in the right triangle EDA, the square of the hypotenuse equals to the sum of the squares of the perpendiculars, that is to say AE squared equals to AD squared plus ED squared. So AE squared, put into equation number 2, equals to AD squared. AD equals to 3, so AD squared is 3 squared. 3 squared is 9, plus ED squared. ED equals to A, so ED squared is A squared. In conclusion, found out that AE squared equals to 9, AE squared equals to 9 plus AE squared. Actually, A equals to 1 plus A, so we substitute AE by 1 plus A, according to equation number 2. AE is 1 plus A, so A squared is 1 plus A squared, and it is equal to 9 plus A squared. Here we will open the brackets on this side of equation number 2, and we get that according to equation number 2, 1 plus A squared equals to 1 plus A squared plus 2A, and it is equal to 9 plus A squared. Here we have A squared on both sides of equation number 2, so A squared will get cancelled, and we left only with 1 plus 2A, that is equal to 9, according to equation number 2. So here we got that according to equation number 2, 1 plus 2A equals to 9. Here we'll subtract 1 from this equation number 2, and we'll get that 1 minus 1 is 0. So here we left only with 2A, that is equal to 9 minus 1, that is 8. So in conclusion, we got that according to equation number 2, 2A equals to 8. Here we will divide this equation number 2 by 2, and we get that here A equals to 8 over 2, that is 4. So A equals to 4 according to equation number 2. Here we can write down that A equals to 4, therefore A plus 1 will be equal to 5. We'll define angle AED as alpha. So in the right green triangle, triangle EAD, we know that cosine alpha equals to ED over EA. And cosine alpha in the right triangle EAD equals to ED over EA. We already found out that ED equals to 4, so we substitute ED by 4, and EA equals to 5, so we substitute EA by 5, and so we actually found out that cosine alpha equals to 4 over 5. In the next step, I will present to you a new law, that is the law of cosines, and we will implement the law of cosines in triangle EBC. So what is the law of cosines? The law of cosines is true in any triangle. So actually, if we have triangle ABC, that could be any triangle. This is triangle ABC, and we know that the length of side AB equals to A units, the length of side AC equals to B units, and the length of side BC is C units. And we also know that the angle between side AB and side AC is alpha. Then, according to the law of cosines, C squared equals to A squared plus b squared minus 2 times a times b times cosine alpha. Okay, this equation is true in any triangle. So we'll implement the law of cosines in our triangle, triangle EBC. This triangle. If A will be equal to EB, B will be equal to EC, and C will be equal to BC, that is actually X. So we will focus on triangle EBC. In triangle EBC, according to the law of cosines, we will get that EB squared, that is actually A squared, plus EC squared, that is actually B squared, minus 2 times EB times EC times cosine alpha it must be equal, according to the law of cosines, it must be equal to C squared. C squared is BC. So C is BC, so C squared is BC squared. BC squared. So this will be equation number 3. I will remind to you that cosine alpha equals to 4 over 5. So we substitute cosine alpha by 4 over 5 here. BC, here BC equals to x, so we substitute BC by x. If BC equals to x, it means that BC squared equals to x squared. If EB equals to 5 plus 5, that is 10. So EB squared, it is actually 10 squared, that is 100. Plus, so EB equals to 10, I'll write it down. Units. What is the length of EC? EC equals to 4 plus 6, and 4 plus 6 is also 10. So EB equals to EC equals to 10. So if EC squared is 10 squared, that is also 100, minus 2 times EB is 10, and EC is also 10. So in conclusion, we found out that according to equation number 3, 100 plus 100 minus 2 times 10 times 10 times 4 over 5 equals to x squared. Here, 100 plus 100 is 200, minus 10 times 10 is 100, and 100 times minus 2 is minus 200. 4 over 5 equals to x squared. Okay? So here we have, according to question number 3, we have minus 200 over 5 is minus 40. So it is 200 minus 40 times 4 equals to x squared. Minus 40 times 4 is minus 160, so we write it down. In conclusion, we found out that 200 minus 160 equals to x squared. 200 minus 160 is equal to 40. So, in conclusion, we found out that, according to question number 3, (200 minus 160 is 40). 40 equals to x squared according to equation number 3. We will take a root out of this equation, equation number 3, and we will get that x equals, according to equation number 3, x equals to the square root of 40. 40 is 4 times 10, so we substitute 40 by 4 times 10. The square root of 4 is 2, so in conclusion, we found out that x equals to 2 times square root of 10 units, or in terms of numbers, it is 6.32 units. I repeat again, the length of line segment X, the line segment that we are looking for, here x, BC that is equal to x, it is equals to either 2 times square root of 10 units, or in terms of numbers, it is equal to 6.32 units. Okay? So we finished with the first method. In the next step, I will present to you how to find out the length of this line segment BC that is equal to x according to the second method. In the second method, we will do another construction. Here, from point A, we'll draw a straight line on DC in such a way that the straight line will be parallel to BC. Okay? We will define the touching point of the straight line from A and DC as E. I repeat again that according to our construction, AE is parallel to BC. I write it down. AE is parallel to BC according to our construction. Okay? AE is parallel to BC according to our construction. In the next step, from point E, we draw a straight line on BC in such a way that the straight line will be parallel to AB. Okay? Here, we will define the touching point of the straight line from point E and BC as F. I will repeat again, according to our construction, EF, line segment EF is parallel to AB. I will write it down, EF is parallel to AB according to our construction. So in quadrilateral AEBF, you have two couples of sides that are parallel to each other. Side AE is parallel to BF according to our construction, and side AB is parallel to EF. And this is exactly the definition of a parallelogram. Therefore, quadrilateral AEBF is a parallelogram. Okay? Quadrilateral ABEF is a parallelogram. And we also have rule number 3. According to rule number 3, corresponding angles between parallel lines are equal to each other. I write it down. Corresponding angles between parallel lines are equal to each other. I will read rule number 3 again. According to rule number 3, corresponding angles between parallel lines are equal to each other. So if you focus on here, actually according to our construction, AB is parallel to EF. AB is parallel to EF according to our construction. Okay? So because of the fact that AB is parallel to EF, we will conclude from it, we will derive from it that those two angles that are defined as corresponding angles that are located between the parallel lines AB and EF are equal to each other. So angle ABC equals to angle EFC. I'll repeat again. Angle ABC and EFC are defined as corresponding angles and are located between the parallel lines AB and EF, therefore they are equal to each other according to rule number 3. But it is given us in the question that this angle ABC equals to theta. So you can write down that angle ABC equals to theta, and from this equation theta equals to angle ABC equals to angle EFC, we will derive that angle EFC is also equals to theta. Okay, so this angle EFC equals to theta. Likewise, according to our construction, AE is parallel to BC. I write it down. AE is parallel to BC according to our construction. And because of the fact that AE is parallel to BC, those two angles are defined as corresponding angles, and they are located between the parallel lines AE and BC, therefore they are equal to each other. Okay, so angle DEA, this angle, is equal to this angle. This is actually angle DCB. And they are equal to each other according to rule number 3, the corresponding angles between parallel lines are equal to each other. Okay, so angle DCB equals to angle DEA according to rule number 3. But this angle DCB equals to theta according to what is given us in the question. So we can write here that angle DCB equals to theta. And from this equation, angle DCB equals to theta. And from this equation, theta equals to angle DCB equals to angle DEA. We will derive that angle DEA is also equals to theta. Okay, angle DEA equals to theta. In the next step, I will present to you a new rule that is actually rule number 4. According to rule number 4, the opposite sides of a parallelogram are equal to each other. I write it down. The opposite sides of a parallelogram are equal to each other. So I'll read rule number 4 again. According to rule number 4, the opposite sides of a parallelogram are equal to each other. So if we focus on parallelogram AEBF, if the letter P is the abbreviation for parallelogram. So in parallelogram AEBF, according to rule number 4, AB equals to EF. AB equals to EF according to rule number 4, that the opposite sides of a parallelogram are equal to each other. But it is given in the question that AB equals to 5 units. Here, AB, you can write down that AB equals to 5 units according to what is given in the questions. And from this equation, 5 equals to AB equals to EF. We will derive that EF is also equals to 5. Okay? EF is also equals to 5. We'll focus on triangle EFC. In triangle EFC, we know that angle EFC equals to angle ECF and both angles are equal to theta. Both those angles are equal to theta. Therefore, according to rule number 1 that states that in front of equal angles in the triangle there are equal sides, we will get that side EF equals to side EC. EF equals to EC according to rule number 1, of course. But we just right now found out that EF equals to 5 units. Here EF equals to 5 units. And from this equation 5 equals to EF equals to EC, we will derive that EC is also equals to 5 units. EC is also equals to 5 units. Here we can write down that EC equals to 5 units. And what is the length of the small line segment DE? From the drawing it is very easy to see that DE equals to DC minus EC. I repeat again, DE equals to DC minus EC. So DE equals to DC minus EC. DC equals to 6 units according to what is given us in the question. So we substitute DC by 6. EC, we just right now found out that EC equals to 5 units, so we substitute EC by 5. So in conclusion, we found out that DE equals to 6 plus 5, 6 minus 5. So DE equals to 6 minus 5, that is 1. So here DE equals to 1 unit. You can write here that DE equals to 1 unit. So we'll focus on the right small triangle, triangle ADE. And in the right small triangle, the right small green triangle, triangle ADE, we will implement the Pythagoras theorem on the right green small triangle, triangle ADE. So in the right green triangle, triangle ADE, according to the Pythagoras theorem, the square of the hypotenuse equals to the sum of the squares of the perpendiculars by PT, is a abbreviation for Pythagoras theorem. The square of the hypotenuse is AE squared. And it is equal to the sum of the squares of the perpendiculars, that is to say it is equal to AD squared plus DE squared. I repeat again, according to the Pythagoras theorem on the green right triangle ADE, AE squared equals to AD squared plus DE squared. This is equation number 1, so according to equation number 1, AE squared equals to AD squared. AD equals to 3 units, according to what is given as the question, so AD squared is 3 squared, that is 9, plus DE squared. DE equals to 1, so DE squared is 1 squared, that is 1. So in conclusion, we found out that according to equation number 1, AE squared equals to 9 plus 1, that is 10. So according to equation number 1, AE squared equals to 10. Here we will take root out of this equation, equation number 1, and we will get that AE, according to equation number 1, AE equals to the square root of 10 units. Okay, AE equals to the square root of 10 units, according to equation number 1. So we can write here that AE equals to the square root of 10 units. Now, according to equation number 4, the opposite sides of a parallelogram are equal to each other. So in parallelogram AEBF, we will get that AE is equal to BF, according to equation number 4. AE is equal to BF, according to rule number 4. Okay? But we just right now found out that A equals to the square root of 10 units. So we can write here that A equals to the square root of 10 units. And from this equation, AE equals square root of 10 units equals to AE equals to BF. We will derive that BF is also equals to square root of 10 units. Okay, BF equals to the square root of 10 units. So we can write here that BF equals to the square root of 10 units. And what is the length of line segment FC? From the drawing, it is very easy to see that the length of line segment is FC equals to BC minus BF. BC minus BF. Again, BC minus BF equals to FC. So FC actually equals to BC equals to X, according to what is given as the question. And we just write down found out that BF equals to the square root of 10 units. So, in conclusion, we actually found out that FC equals to X minus square root of 10 units. So we can write here that FC equals to X minus square root of 10 units. This is equal to FC. In the next step, we'll make a construction from point E. We'll draw perpendicular on FC. Okay. I'll repeat again, from point E, we draw perpendicular on FC, so here actually this angle equals to 90 degrees and this angle will be also equal to 90 degrees according to our construction. And we define the touching point of the perpendicular from point E and FC as M. So what is the definition of the line segment EM? EM is a perpendicular from point E on FC. This is exactly the definition of the height. In triangle, the isosceles triangle EFC, EM is the height to FC. Why? Because it is perpendicular to FC, and therefore EM is the height to FC. So, first of all, we know that triangle EFC is an isosceles triangle. Why triangle EFC is an isosceles triangle? Because of the fact that EF equals to EC equals to 5 units. So I write it down. Triangle EFC is an isosceles triangle because of the fact that EF equals to EC equals to 5 units. EF equals to EC equals to 5 units. So triangle EFC is an isosceles triangle the base of the isosceles triangle EFC is FC. FC is the base. FC is the base of the isosceles triangle EFC. Okay, FC is the base. And EM is the height to the base FC. EM is the height to the base FC. Why EM is the height to the base? Because of the fact that line segment EM is perpendicular to FC. And when you have a line segment that is perpendicular to side of the triangle and it exited from the vertex, then this is exactly the definition of the height. Therefore, EM is the height to the base FC of the isosceles triangle EFC. Okay? And here we have also rule number 5. According to rule number 5, the height to the base in an isosceles triangle bisect the base. So I'll read rule number 5 again. According to rule number 5, the height to the base in an isosceles triangle bisect the base. Okay? The height to the base in an isosceles triangle bisect the base. So here if you focus on the isosceles triangle EFC, according to rule number 5, the height EM to the base FC bisects the base FC. What does it mean that it bisects the base FC? It means that it divides it to 2 equal parts. So the first part, FM, will be FC over 2, and the second part, MC, will be also FC over 2 according to rule number 5. Okay? So FM equals to FC over 2, and MC is also equals to FC over 2. I'll write it again. FM equals to FC over 2, and MC is also equals to FC over 2. Okay? That is to say, FM from those 2 equations, FM equals to FC over 2 and MC equals to FC over 2, from those 2 equations we derive that FM equals to FC, if FM equals to MC, equals to FC over 2. Fm equals to MC equals to FC over 2. FC equals to x minus square root of 10 over x minus square root of 10, and FC over 2 equals to x minus square root of 10 over 2. So in conclusion, we actually found out that MC, that is equal to FC over 2, it is equal to x minus square root of 10 over 2. X minus square root of 10 over 2. Again, according to rule number 5, the height EM to the base FC bisects the base FC into two equal parts. That is to say, FM equals to MC equals to FC over 2. And therefore, MC equals to FC over 2, it means that MC equals to FC, that is x minus square root of 10 over 2. Okay, so we actually found out that MC equals to x minus square root of 10 over 2. And in the next step, we will prove that those two right triangle, the green right triangle AED is similar to the green big triangle, triangle E, the right triangle, triangle EMC. So why those two right triangles are similar to each other? So we focus on the small green right triangle, triangle ADE, and the big green right triangle, triangle EFC. Why those two right triangles are similar to each other? First of all, in this right triangle, triangle EFC, the triangle EMC, is actually triangle EMC, triangle EMC. In this right green triangle EMC, this angle equals to 90 degrees, this angle equals to theta, so this angle must be equal to 90 degrees minus theta in order to complete the sum of the angles in this right triangle 280 degrees. This angle must be equal to 90 degrees minus theta. Likewise, in the small right green triangle ADE, this angle equals to theta, this angle equals to 90 degrees, therefore this angle must be equal to 90 degrees minus theta. So actually those two angles, they are both equal to 90 degrees minus theta, therefore they are equal to each other. So actually angle EAD, this angle, is equal to this angle, this is actually angle MEC, and both angles, they are equal to 90 degrees minus theta. In addition, those two angles, they are both equal to theta, therefore they are equal to each other. So angle DEA is equal to angle ECM and they are both equal to theta. And finally, those two angles are both equal to 90 degrees, therefore they are equal to each other. So angle EDA equals to this angle, that is the equal angle EMC. And both angles are equal to 90 degrees. So actually, those two angles are equal to each other, they are both equal to 90 degrees. Those two angles are both equal to 90 degrees, therefore they are equal to each other. Those two angles are both equal to theta, therefore they are equal to each other. So all the angles of triangle ADE can go into all the angles of triangle EMC. Therefore, triangle ADE is similar to triangle EMC according to angle similarity rule. Okay, so I write it down. Triangle ADE is similar, this is the sign of similar to triangle EMC according to angle similarity rule. And from the fact that those two triangles are similar to each other, hence we will conclude that AE over EC is equal to DE over MC. I'll repeat again. From the fact that triangle ADE is similar to triangle EMC, we conclude that AE over EC equals to DE over MC. So according to equation number 2, AE equals to square root of 10 units, so we substitute AE by square root of 10 units. Over EC, EC equals to 5 units, so we substitute EC by 5. And it is equal to DE. DE equals to 1 unit, so we substitute DE by 1 over MC. MC equals to x minus square root of 10 over 2, so we substitute MC by x minus square root of 10 over 2. Okay? So here we will move 2 to the numerator and x minus square root of 10 to the denominator, and we get that according to equation number 2, square root of 10 over 5 equals to 2 over x minus square root of 10. Here we first multiply this equation number 2, and we get that according to equation number 2, square root of 10 times x minus square root of 10 equals to 5 times 10 is 10. And we know that 10 is square root of 10 times square root of 10, so we substitute 10 by square root of 10 times square root of 10, and we get that according to equation number 2, square root of 10 times x minus square root of 10 equals to square root of 10 times square root of 10. Here we divide this equation number 2 by square root of 10, and we get that according to equation number 2, square root of 10 times square root of 10 is 1, so in this side of equation number 2 we left only with x minus square root of 10, and there square root of 10 times square root of 10 over square root of 10, it is square root of 10. So in this side of the equation we left only with square root of 10. Here we add square root of 10 to this equation number 2, and we get that according to equation number 2, x equals to 2 times square root of 10 units, or in terms of numbers it is equal to 6.32 units. So we finished the second method. The answer to the question is that x equals to either 2 times square root of 10 units, or in terms of numbers it is equal to 6.32 units. Here x equals to either 2 times square root of 10 units, or in terms of numbers it is equal to 6.32 units. So in the next step I will summarize the lecture. We start with the first method. So repeat on the question itself. Here we have quadrilateral ABCD. Side AB equals to 5 units, AD equals to 3 units, DC equals to 6 units. Angle ADC equals to 90 degrees. Angle DCB equals to angle ABC equals to theta. And we want to find out the length of side BC that is equal to x. So in the first method we did the construction. We extended side BA and side CD until they intersect with each other at point E. So here we created triangle EBC that has two angles that are equal to each other. Those two angles are both equal to theta. Then I presented to you rule number 1. According to rule number 1, in front of equal angles in the triangle there are equal sides. So here in triangle ABC we have two angles that are equal to each other, they are both equal to theta, and in front of those two equal angles we have side EC and side EB. Therefore, according to rule number 1, EB equals to EC. According to rule number 1, EB equals to EC, EB equals to 5 plus AE, EC equals to 6 plus ED. Here we subtracted 5 from this equation and we found out that AE equals to 1 plus ED. We defined ED as A, so we substituted ED by A and we got that AE equals to 1 plus A. So here ED equals to A and EA equals to 1 plus A, that is 5. Then we have, before we did the construction, we had a quadrilateral ABCD. Side CD, line segment CD is one side of quadrilateral ABCD, therefore it is absolutely a straight line. And then when we extended the straight line by a straight line, the result is EC, that is also must be a straight line, because when you extend a straight line by a straight line, the result must be a straight line. Therefore, the result that is EC must be a straight line. Okay? So here EC is the straight line, and we have also rule number 2, that the sum of the angles on one side of a straight line is equal to 180 degrees. So actually, if we focus on this side of the straight line EC at point D, then the sum of the angles must be equal to 180 degrees. So which angles we have at this side of EC at point D? We have here 90 degrees and then angle EDA. That is to say, 90 degrees plus angle ADE must be equal to 180 degrees according to rule number 2. If we subtracted 90 degrees from this equation and found out that angle ADE equals to 180 degrees minus 90 degrees, it is 90 degrees. So we found out that this angle is a right angle, therefore the green triangle is a right triangle. So angle triangle AED is a right triangle. So we can implement the Pythagoras theorem on the right triangle AED. Okay? According to the Pythagoras theorem, the square of the hypotenuse equals to the sum of the squares of the perpendiculars, that is to say, AE square equals to AD square plus ED square. AE square equals to AD square. AD equals to 3, so AD square is 3 square, that is 9. So AD square is 9 plus ED square. Here AD equals to A according to our definition, so ED square is A square. So in conclusion, we found out that according to equation number 2, AE square equals to 9 plus A square, but AE equals to 1 plus A, so we can substitute AE by 1 plus A. So we substituted AE by 1 plus A, and we got that according to equation number 2, 1 plus A square equals to 9 plus A square. We open the brackets on this side of equation number 2, and we got that 1 plus A square equals to 1 plus A square plus 2A, and it is equal to 9 plus A square. Here we have A square on both sides of the equation, so A square will get cancelled, and we left only with 1 that is equal to 1 plus 2A that is equal to 9. Okay, I found out that 1 plus 2A equals to 9 according to equation number 2. We subtracted 1 from this equation number 2. So here 1 minus 1 is 0, so here we have 2A that is equal to 9 minus 1, that is 8. So in conclusion, found out that according to equation number 2, 2A equals to 8. We divided this equation number 2 by 2. And we got that 2A over 2 is 8, 8 over 2 is 4. So in conclusion, we found out that A equals to 4 units. So here A equals to 4 units, and A plus 1, of course, equals to 5. Then, in this green right triangle, AED, cosine alpha equals to ED over AE. Green right triangle AED, cosine alpha equals to ED over AE or EA. ED equals to A according to our definition, when A equals to 4, and AE equals to A plus 1, that is 5. So we substituted ED by 4 and EA by 5, and in conclusion we found out that cosine alpha equals to 4 over 5. Okay, then we implemented I presented to you the law of cosines, and then we implemented the law of cosines in this triangle BEC, that is actually an isosceles triangle. So what is the law of cosines? The law of cosines is true in any triangle. If we have triangle ABC, that could be any triangle. And we know that side AB in this triangle equals to A units in its length, side AC equals to B units in its length, and side BC equals to C units in its length. And the angle between side AB and side AC equals to alpha, then according to the the law of cosines, we will get that c squared equals to a squared plus b squared minus 2 times a times b times cosine alpha. We can use this equation in any triangle. So we implemented the law of cosines in our triangle EBC. In this triangle, EB equals to A, EC equals to B, alpha is alpha, and BC that is equal to X is C. So according to the law of cosines, we will get that A squared is EB squared plus B squared that is EC squared, so it is EB squared plus EC squared minus 2 times AB is 2 times EB times EC times cosine alpha. And this is equal to BC squared. C squared is BC squared. That is actually X. BC is X, so BC squared is X squared. EB equals to 5 plus 5, that is 10. EC equals to 4 plus 6, that is also 10. And EC equals to 4, and cosine alpha equals to 4 over 5. So we substituted cosine alpha by 4 over 5. We substituted BC squared by X squared. We substituted EC by 10, EB by 10. So EC squared is 10 squared, that is 100. EB squared, that is also 10 squared, that is also 100. So we will have here EB squared plus EC squared minus 2 times EB times EC times cosine alpha equals to BC squared. So here we have 100 plus 100 minus 2 times 10 times 10 times 4 over 5, that is cosine alpha equals to X squared. 100 plus 100 is 200. So here we have 10 times 10 in 100, and 100 times minus 2 is minus 200. So it is minus 200 times 4 over 5 equals to X squared. Here we have 200 over 5 is 40. So this expression equals to minus 40 times 4. So in conclusion, we found out that 200 minus 40 times 4 equals to X squared. So minus 40 times 4 is 160. So in conclusion, we found out that 200 minus 160 equals to X squared. Here 200 minus 160 is 40. So in conclusion, we found out that according to equation number 2, 40 equals to X squared. We took the root out of this equation, equation number 3, and we got that X equals to the square root of 40. 40 is 4 times 10, so we substituted 40 by 4 times 10, and we got that X equals to square root of 4 is 10, so in conclusion X equals to either 2 times square root of 10 units, or in terms of numbers it is equal to 6.32 units. We finished with the first method. In the next step, I will present to you how we found out the length of line segment BC that is equal to X according to the second method. Okay. In the second method, we did another construction. From point A, we draw a straight line in such a way that AE will be perpendicular to BC. So AE is parallel to BC. AE, we draw the straight line in such a way that AE will be parallel to BC. So AE is parallel to BC according to the construction. And then from point E we draw a straight line on BC in such a way that EF will be parallel to AB. EF is parallel to AB also according to our construction. So quadrilateral ABF is a parallelometer. Why? Because it has two couple of sides that are parallel to each other. AE is parallel to BF and AB is parallel to EF, and this is exactly of the definition of a parallelometer. parallelogram. Okay, so again, quadrilateral AEBF is a parallelogram. And actually, we have rule number 3, according to rule number 3, corresponding angles between parallel lines are equal to each other. Here we know that according to our construction, AB is parallel to EF. Therefore, according to rule number 4, those two angles are equal to each other. Those two angles that are defined as corresponding angles and are located between the parallel lines AB and EF will be equal to each other. That is to say, angle ABC equals to angle EFC according to rule number 3. But it is given as the question that angle ABC equals to theta. Here, angle ABC equals to theta according to what is given as the question. So from this equation, theta equals to ABC, so angle ABC equals to angle EFC, we derive that angle EFC is also equals to theta. So this angle EFC is also equals to theta. Likewise, according to our construction, AE is parallel to BC, AE is parallel to BC. So those two angles that are defined as corresponding angles will be equal to each other according to rule number 3. Again, AE is parallel to BC according to our construction, therefore angle DAE will be equal to angle DCB according to rule number 3. But according to what is given as the question, angle DCB equals to theta. So here we can write down that angle DCB equals to theta, and from this equation theta equals to angle DCB equals to angle DEA, we derive that angle DEA equals to theta also. Right, this angle is also equals to theta. Okay? Then I presented to you rule number 4. The opposite sides of a rectangle are equal to each other according to rule number. The opposite sides of a parallelogram are equal to each other according to rule number 4. That is to say, the opposite sides of parallelogram AEBF are equal to each other. In parallelogram AEBF, the opposite sides are equal to each other. That is to say, AB equals to EF. AB equals to EF. But it is given as the question that AB equals to 5. So here AB equals to 5. So from this equation 5 equals to AB equals to EF, we derive that EF is also equals to 5. Okay, here EF is also equals to 5. And in triangle EFC, those two angles are equal to each other, they are both equal to theta. Therefore, according to rule number 1, that the front of equal angles in the triangle there are equal sides, we get that EF equals to EC. Again, in triangle EFC, we know that angle EFC equals to angle CF equals to theta. Therefore, according to rule number 1, that the front of equal angles in the triangle there are equal sides, we get that EF equals to EC. But EF equals to 5 units. We found out that EF equals to 5 units, so we can write here that EF equals to 5 units, and from this equation 5 equals to EF equals to EC, we derive that EC is also equals to 5 units. Here EC is also equals to 5 units. So, and what is the length of the short line segment DE? DE equals to DC minus EC. Again, DE equals to DC minus EC. DC equals to 6 units. EC equals to 5 units, so D equals to 6 minus 5, that is 1. So we found out that the short line segment DE equals to 1 unit. Then we implemented the Pythagoras theorem on this short right triangle ADE. The square of the hypotenuse equals to the sum of the squares of the perpendiculars, that is to say, AE square equals to AD square plus DE square. In the right triangle ADE, AE square equals to AD square plus DE square. AE square equals to AD square. AD equals to 3, so AD square is 3 squared, that is 9, plus DE square. DE equals to 1, so DE square is 1 squared, that is 1. So in conclusion, found out that AE square equals to 9 plus 1, that is 10. According to equation number 1, AE square equals to 10. We took out of this equation number 1, and we got that AE equals to square root of 10 units. So this AE equals to square root of 10 units. Then according to equation number 4, the opposite sides of a parallelogram are equal to each other. That is to say, AE will be equal to BF. AE will be equal to BF according to rule number 4. But we just right now found out that A equals to the square root of 10 units. So from this equation, square root of 10 units equals to AE equals to BE. We will derive square root of 10 units equals to AE equals to BF. We will derive that BF is also equals to 10 units. Here, BF equals to 10 units. And what is the length of line segment FC? From the drawing, it is very easy to see that FC equals to BC minus BF. Again, FC equals to BC minus BF. BC equals to X, according to what is given as the question. We just right now found out that BF equals to square root of 10, so in conclusion found out that BFC, if FC equals to X from square root of 10 units. Okay, then we focused on the isosceles triangle, triangle FEC. First of all, triangle FEC is an isosceles triangle. Why triangle FEC is an isosceles triangle? Because of the fact that side FE equals to side EC equals to 5 units. Therefore, triangle FEC is an isosceles triangle because the F equals to EC equals to 5 units. And the base of the isosceles triangle EFC is FC. Again, FC is the base of the isosceles triangle, triangle EFC. And FM and here. Then actually we did a construction from point E, we drew perpendicular on FC. So EM is perpendicular to FC. That means, that is to say, this angle equals to 90 degrees and this angle equals to 90 degrees according to our construction. Then I presented to you rule number 5. But before that, emphasize that EM is the height to the base FC. Again, EM, line segment EM is the height to the base FC. Why? Because it is perpendicular to FC, therefore it is the height to side FC. Again, EM is the height to the base FC. Because it is perpendicular to FC, it is the height to the base FC. Okay? And then I presented to you rule number 5. According to rule number 5, the height to the base in an isosceles triangle bisect the base. So here, according to rule number 5, the height EM to the base FC bisects the base FC. It means that it divides the base FC into 2 equal parts. That is to say, the first part is FM, the second part is MC, and according to rule number 5, FM equals to FC. Okay? According to rule number 5, Fm equals to MC. But what is the length of each equal parts? It is half of the length of the base FC. That is to say, Fm equals to Fc over 2, and Mc is also equal to Fc over 2. So here, Fm equals to Mc according to rule number 5, and the length of each part is half of the length of Fc. That is to say, it is equal to Fc over 2. Again, the height to the base in an isosceles triangle bisects the base. So the height EM to the base FC bisects the base. That is to say, it divides the base FC into two equal parts. So the first part is FC over 2, and the second part is also FC over 2. That is to say, Fm equals to Fc over 2, and Mc is also equals to Fc over 2. So, and it divides the base into two equal parts. That is to say, Fm equals to Mc. Okay? So in conclusion, we actually found out that Fm equals to Mc equals to Fc over 2 according to rule number 5. And what is Fc over 2? Fc is x minus square root of 10. Therefore, Fc over 2 will be equal to x minus square root of 10 over 2. Okay, so here Mc, it is Fc over 2. Fc equals to x minus square root of 10. Therefore, Fc over 2 is x minus square root of 10 over 2. In conclusion, Mc equals to x minus square root of 10 over 2. Okay? I'll repeat on rule number 5 again. The height to the base in an isosceles triangle bisects the base. So the height EM to the base FC of the isosceles triangle EFC bisects the base. That means that it divides the base into two equal parts. So the first part will be Fc over 2, and the second part will be also Fc over 2. That is to say, Fm equals to Mc equals to Fc over 2. Fm equals to Mc equals to Fc over 2. So each part equals to Fc over 2. It means that Mc equals to Fc over 2. Fc is x minus square root of 10. Therefore, Fc over 2 equals to x minus square root of 10 over 2. In conclusion, Mc equals to x minus square root of 10 over 2. Then we actually proved that those two green right triangles are similar to each other. Why those two green triangles are similar to each other? First of all, those two angles are equal to 90 degrees, therefore they are equal to each other. Those two angles are both equal to theta, therefore they are equal to each other. And this angle, in this right green triangle, this angle equals to 90 degrees. This angle equals to theta, therefore this angle must be equal to 90 degrees minus theta. In order to complete the sum of the angles in this right triangle to 180 degrees, this angle must be equal to 90 degrees minus theta. Likewise, for the same reason, because of the fact that this in a right triangle ADE, this angle equals to 90 degrees, and this angle equals to theta, this angle must be equal to 90 degrees minus theta. In order to complete the sum of the angles in triangle ADE to 180 degrees, this angle must be equal to 90 degrees minus theta. In conclusion, those two angles, they are both equal to 90 degrees minus theta, therefore they are equal to each other. Actually, we proved that all the angles of triangle ADE can point to all the angles of triangle EMC, therefore those two right green triangles are similar to each other according to angle similarity rule. And from the fact that those two triangles are similar to each other, we conclude that AE over EC equals to DE over MC. We conclude that AE over EC equals to DE over MC. Again, AE over EC equals to DE over MC. Okay? Here, AE, according to question number 2, AE over EC equals to DE over MC. AE equals to square root of 10 units, EC equals to 5, DE equals to 1, and MC equals to x minus square root of 10 over 2. Here we moved 2 to the numerator and x minus square root of 10 to the denominator, and we got that square root of 10 over 5 equals to 2 over x minus square root of 10. because multiply this equation, equation number 2, and we got that according to equation number 2, square root of 10 times x minus square root of 10 equals to 10. 10 equals to square root of 10 times square root of 10, so we substitute the 10 by square root of 10 times square root of 10, and we got that according to equation number 2, square root of 10 times x minus square root of 10 equals to square root of 10 times square root of 10, that is actually 10. We divided this equation by square root of 10, and we got that according to equation number 2, x minus square root of 10 equals to square root of 10. We added square root of 10 to this equation, equation number 2, and we got that x, the line segment that we are looking for, that is actually equals to BC, equals to either 2 times square root of 10 units, so in terms of numbers, it is equal to 6.32 units. So in both methods, we found out that the line segment BC, that is actually equals to x, it is either equals to 2 times square root of 10 units, or in terms of numbers, it is equal to 6.32 units. Okay? Thank you very much.